AC, you'll see a lot of similarities. Okay, so this is just after page 203. I will guarantee you this on the test, maybe not ACs, but I will guarantee you that there will be a diagram that will help you figure out how many sides there are. That's the first thing you need to do. So count 1, 2, 3, 4, 5, 6. This particular polygon has 6 sides. And if you have a formula sheet, have this out right now. You'll be able to use that for the AC, for the test. If you need one, I have a few extras up front. But just get them out and focus on the front, right? The front page. It starts like just at the bottom here. 1, 2, 3, 4, 5. There are these 5 formulas. If you don't have them on your study sheet, then just use them here. I'll just warn you that it's a little bit different. I gave you n-2 first and then times 180. Like these are flipped, but it doesn't matter at all. You get the same answer. So if you don't want to use your study sheet for these, then just come and grab them from here. You can use both, right? Blue and yellow, we support the Ukraine at the same time, right? And your study sheet. So if you want your study sheet on top of that, which is the blue one, sorry, that's what I meant to say, bring that. So anyways, if this question, and just write this down, right? If the question said, hey, what's the sum of all the interior angles here? There are 5, right? Well, the formula says to take the number of sides minus 2 and multiply that by 180 degrees. I'm just going to zoom into that side, okay? So it's easier to see. Okay, so the sum is essentially 4, right? This gives you 4 times 180. And 4 times 180 will give you 720 degrees as your answer. So all the inside angles here, this one, all of them added up will give you 720, and that's always true. You can always use this formula to figure that out. If it asked you for the measure of one interior angle, I call it I, right? Then you would have to say it's n-2 times 180. So it's essentially the same thing as before, except for here you're going to divide that by the number of sides. Right? So the top gives me 720. I divide that by 6, and I get 120 degrees. This is the measure of one interior angle. So if you want to come over here, just say, write down the 120 in every single corner formed, right, by those lines. Where the lines meet, that's where the interior angle is, right? So 120 all around. If they asked you for a central angle, for example, central, we call it C. The formula, if you go right now, look at the central angle C, it's 360 degrees divided by n, which is 6 in this case. And that would give you 60 degrees for the central angle. So that's that. If it asked you for the exterior angle, I will label that in a bit. Exterior angle is 360 divided by n as well. Central and exterior will always be the same. Okay. And ice, right? Winter peg, ice, you should be very familiar with that word. That can be labeled, right? So interior angle, just pick one of them and just put an I right next to it, right? If you want a central angle, you got to go find the middle and just cut it like that. That right there is what we call the central angle. And the exterior angle, watch this. Biggest mistake is students go to the corner and then they just go out like that. That is not the exterior angle. I know I repeat myself, but just pick one of the sides. I pick the bottom and travel on it. It doesn't matter which side you travel to. And when you get to the corner, you just keep on going the same direction. That is one exterior angle right there. There are 5 of them, okay? Sorry, 6 of them in this case because there are 6 sides. And so that's what you do. Let's do this. Let's write this down because these are our notes, right? This is your exterior angle. This is your central angle. This is your interior angle, the 120. And this is a sum of interior angles. Sum is the addition of all interior angles, right? And I'm missing one. I'm pretty sure I'm going to be able to fit that in. Here we go. The number of diagonals you can draw in the shape. Diagonal, look at the formula. It's kind of scary, but you can handle it. N times n minus 3 divided by 2. So n times n minus 3 divided by 2. 6 times 6 minus 3 is just 3. And you divide that answer by 2. So 6 times 3 is 18, divided by 2 is 9. So sorry, this is dangerous here. Right, these are your diagonals. You'll be doing that on the AC shortly, okay? So all of them are there. So for every single one of these, I use the formula on my formula sheet, right? So just read carefully and pick the corresponding formula to answer that. All right. At this point, you can close everything. Right? Close this booklet. You can leave it on your desk because we're going to come right back to this. But just close it for now. And first question, label one interior, exterior, and a central angle. So you grab any one of these corners and put an eye there. That's telling me that this is the interior. You got 1 mark for that. An exterior, you grab any side and you just extend it like that. That is your exterior. And central, you need to find the middle and just make a pizza slice. And that angle formed between those 2 cuts is your central angle. Okay, so 3 marks for that. As long as you know where they are, you get 3 marks. Calculate the sum of interior angles. I got to go back 1 second and just count. 1, 2, 3, 4, 5, 6, 7, 8, 9. I make a note that this particular polygon has 9 sides. That's what you need, the number of sides, and then everything else just comes together. The sum is this formula, right? That's the one you want to use. So it's 9 minus 2 times 180. Just do this quickly, right? So you don't make a mistake while typing that in. So 7 times 180, that's 1260. 1260 degrees. You get 1 mark for that. Okay, so it's not dividing. You don't divide for the sum. The sum is always a bigger number. Okay, if you divide it, take off 1 mark. Okay, calculate the measure of one interior angle. Just 1, right? That's where this formula comes in. It's n minus 2 times 180 divided by n. You substitute in, right? That's 9 minus 2 times 180 divided by 9. The top part is exactly the same as up here. So I'm just going to borrow that number and divide that by 9, and you get 140 degrees. You get 1 mark if you have that. Okay. calculate the measure of one exterior angle, right? Exterior is the key here. You go look at your formula sheet and it says there, exterior angle, take 360 divided by the number of sides. So 360 divided by 9, that's 100, sorry, not 100, that's just 40 degrees. Done. You got a mark for that. Calculate the central angle. It's the exact same formula as the exterior. That is 40 degrees as well. You get 1 mark for that. The number of diagonals. So diagonal is n times n minus 3 divided by 2, which means wherever there's an n, you plug in this case, 9. Whatever the number of sides would be, that's what you plug in there. Okay, so that's 9 times 6 divided by 2, and that is 27. 27 diagonals can be drawn on this particular polygon. The sum of all exterior angles is always 360. It doesn't matter. Yeah. You have a question, Nicola? Is that for this one? It's always 360. Did you get 360? Okay. As long as you get 360, you get it. Yeah. But it's regardless, sorry, of sides, right? Like it doesn't matter if it's a 50-sided polygon, it will always add up to 360, as long as you remember that. Okay, so this page is out of 1, 2, 3, 4, 5, 6, and 3, so 9. This page is worth 9 marks. So let's see how you did there. Backside. I'll make question 2 a bonus because I didn't do an example on this one. But I have a feeling that some of you probably guessed it or you tried something. So this is not going to be out of 2. It's just a bonus. And you get maximum 1 bonus mark, right, for this if you did this right. Because this is what I expect, okay? It's telling you that the central angle is 20 degrees. That's C. How many sides does it have? It's asking you to figure out n. So it's a good one to write down because I'm going to expect you to do that after. Yeah. What is it? It is 18. It is 18. So if you guessed it or whatever, you get a bonus mark. How's that? But from now on, I expect you to do that. They're giving you the central angle, so you start with the formula. If you want to get the marks moving forward, and I'll give you more examples today, this is what you start with because they give you the central angle. You substitute, right? You put the 20 in here. And then leave the rest as is. Okay? You put a 1 underneath the 20 to see that you have to cross multiply like this. Because if you put a 1, it doesn't affect the 20 at all. So n is 360 times 1 divided by 20, which, yes, it's 18 sides. Not 18 degrees, 18 sides. Okay? Next, consider a regular hexagon. That should tell you that n is equal to 6. So if you use 7 or 5, I would immediately take off 1 full mark for everything, and then we'll just ignore that you got that wrong. Okay, as long as you use the correct formula. So sum is n minus 2 times 180. And that is 720 degrees. Didn't I just do that one? Yes, I did. Central angle is 360 divided by the number of sides. So that's 60 degrees. The measure of one interior angle. Interior angle is n minus 2, right? So 6 minus 2 times 180 over 6. That is really 720 degrees divided by 6, which is 120. 1 mark. Number of diagonals, n times n minus 3 divided by 2, which is 6 times 3 divided by 2, which is 9. 9 diagonals can be drawn on a hexagon. Measure of one exterior angle, 360 divided by 6. That's also 60 degrees. And I'm just using the formulas, right? So 5 marks for question 3. Just give yourself 1 mark for each correct entry. And then question 4. So 4 out of 5. Like you use a different number for n, 4 out of 5. As long as you use the right formulas. Yeah. So again, you don't have to memorize. I will give you a diagram on the test. Because I'll be using like 16, 17 sided or whatever. Just count, right? Just count the number of sides. Did I just say something? I didn't say anything. Consider the following 5-sided polygon. Determine the sum of interior angles. It's a 5-sided polygon. So the sum would be 5 minus 2 times 180, which is really 3 times 180, which is really 540 degrees. So you get a mark for that one. All of them add up to 540. Now you want x, right? This angle right here. I will just do this to find x, because watch this. 1, 2, 3, 4, 5 sides. This is technically a 5-sided polygon. So 540 minus, I'm going to take away the 290s, minus 151 minus 149. So you subtract the ones you know from 540 and you're left with, is it 100 and no, sorry, way off, 60. I was thinking a different example here. 60 degrees. So all you started off, this comes with you here, right? If this had been a 6-sided polygon, then you would start with 720 and subtract the ones you know, right? So just use this skill to figure out the missing angle, okay? Is this a regular polygon? This one here? It's irregular, right? What needs to happen for this is just a bonus, right? What needs to happen for something to be regular? 2 things need to be true. All angles are the same and all sides are the same. So a square, an equilateral triangle, stuff like that, okay? Angles are not congruent, right? It fails the angles test. We don't care about the sides. We don't even need to go there. We just know it would fail, so immediately it's irregular. So this page is actually out of 7. It's out of 7, but you could score 8 because of that bonus, right? So the bonus is just 1 mark. If you guessed 18, today is your day. You should go buy a lottery ticket. No, I'm just kidding. Don't do it. And so this is out of 16 then. 16 total. You could score 17 if you got 8 and 9, right? But if you didn't get the bonus, then the maximum you could score is 16 out of 16. But this is probably one of the last things that I will AC you on tomorrow, and it will be on the test. Something like this, okay? So just pay close attention. And it's not that bad, but I'm kind of mixing things up here a bit. It says here, calculate the value of the specified side which in this case is x, right? And then B, it's saying determine the perimeter of this polygon. Just a quick review of perimeter. Perimeter is the distance around, right? The distance around the shape is our perimeter. So let's do one at a time. Watch carefully. If this is 13 inches, then this will also be 13 inches. It's an isosceles triangle. Okay? What do we call this angle right here? This angle is called the central angle. So let's put a C here. That angle is central angle. If I find this angle, what kind of a triangle do I have? Side, angle, side. SAS, cosine law, right? Some of you are saying SOS. Get me out of here. But anyway, so let's find step one. Step one, find central angle. That would be the first step you should take here. So central angle is found by taking 360 and dividing it by the number of sides. And so you have to count, right? I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make a note right here on the side. This is a decagon, 10 sides, right? So we divide it by 10 to get 36 degrees. I'll probably give you a mark already for that. So let's bring this 36 in here. Maybe I will use a red pen so that you know it wasn't there before, right? So this 36, it gets inserted there. And now you have an SAS triangle, right? Which means we have to use cosine law. And I will do that just underneath here. Watch this. If you want to find that, right, the formula says that you take that side squared and then the other side squared plus the other side squared, which they're both the same, right, minus 2 times the first one times the second one times cosine of 36 degrees. I want you to remember how to do this. So can you type this in and see what you get? Because that was a bit of a problem last test. So type this in and see what you get. I will do the same. I will put step 2 here. Step 2 at the top. So 13 squared plus 13 squared minus 2 times 13 times 13 times cosine of 36. And I get 64.552, and that keeps going. So I can just press the square root button, and I get 8.03. 8.03. And we are in inches, right? So make sure you add that. So this would be finding x, right? That one side of this polygon. We're good, okay? Step 3, perimeter. Let me just focus that one more time here. And how do you find the perimeter? Let's just do this for polygons. It's the number of sides, right, multiplied by x in this case. If I take the number of sides, in this case it's 10, we multiply it by x, which is 8.03. When we multiply those two, you get 80.3 inches, and this is the perimeter of that polygon. One more thing, okay, so you're not thrown off. The central angle had happened to be a nice, beautiful 36. That could be a decimal very easily. So just use two decimals, right? Like if you get 36.70, right, or 36.54, you use 36.54 if that's what you're getting, right? It just happened to be a round number here. Before I move on, right now, I want you to practice with the one that's right next to it. Count the number of sides first, then do everything I just did, okay? Make it quick and equalize, right? You know what I mean? Okay. So practice this with that polygon right next to it, okay? Before I move on. That way you have done it once, and you know Z or Z, right, is 13.80 feet, and the perimeter would be 151.8 feet. So write this down if you didn't get it, so you can double check. Again, this is combining cosine law with everything else we've learned. There are other ways of figuring this out, folks. You could use sine law. I don't know if anybody caught on to that. This is an isosceles triangle, so technically you would be able to find these two base angles here. Subtract it from 180 divided by 2. I'm not going to go there because I think cosine is the quickest. So, but you would get the same final answer. Only have 15 minutes left, so I'm kind of going to push you a little bit, sorry. Okay, next, a regular polygon. This is the one I was talking about. I never got to it yesterday. A regular polygon has exterior angle of 40 degrees, so they're giving you the exterior angle. Calculate the number of sides, so they're asking you for the number of sides. I want you to start with the formula for that particular angle. Exterior angle is 360 divided by n. Then you take the 40 and you will be substituting on the left side. So that's how this one is different, right? 40 is equal to 360 over n. Then you put the 1 underneath just to see that, oh yeah, this is basically two fractions, right? You cross multiply and divide. So n is really 360 times 1 divided by 40. And in this case, it would be 9 sides. 9 sides for this one. Can you put this on the somewhere here? Backwards. This is a backwards example where you go from the angle to the number of sides. So this is kind of what I would expect you to do. If you're going to guess, you can guess, but you're not going to get the marks, right? I need to see the steps. It's more about the algebra than it is the final answer. And I'll show you another one like this, which is a little bit more complicated. Just a little bit, not that much more. This would be the easiest of the backwards questions. So go to the next page here with me, follow me, and we're gonna scratch this one because it's too easy. We've done that already. Just cross that off, and instead I'm gonna give you a different question there. So please write this down. Above it, we're gonna write down the sum of interior angles, right? The sum of interior angles of a polygon is 1800, let's say. 1800 degrees. Write that down. The sum of interior angles of a polygon is 1800 degrees. And then if I hope it fits here for you, calculate the number of sides. Okay? Sorry, there we go. The sum of interior angles of a polygon is 1800. Calculate the number of sides. So all you have to do here is to focus on this. The sum is 1800, right? So there you should be thinking of the letter S for sum, right? And so they want the number of sides, like what would be the number of sides there? So you start with the formula. Sum would be n minus 2, just right? That is basically copying the formula down. Then you take the 1800 and you plug it in, right? I know you've seen this kind of stuff before. I know that, right? Unless COVID got in the way, which it did actually for almost everybody, right? You didn't quite learn probably everything you were supposed to. So you substitute in the 1800. What would you do now? Divide by 180 because you slowly want n to be on its own. So watch this. I'm using red so you can see we're going to divide both sides by 180, which allows me to do this. That's exactly what I want happening. This you do on your calculator. What's 1800 divided by 180? It'd be 10, right? Use your calculator if you're not sure. So 10 is equal to, all you have left on the right side is n minus 2. That's all you have left. And this is where your teachers probably told you, hey, just add 2 to both sides like that, which will leave you with n, and on the other side you'll have 12. Right? So 12 sides. Just for fun, we're going to name it. It's actually a dodecagon, right? 12 sides. I will not ask you to go that high. I might ask you, hey, what do you call a 5-sided polygon? You should know that that's a pentagon, right? Put a star here. That will be a bonus if I have time for that. It could be a bonus, I will say. It could be a bonus. So I won't do that today. Just make sure you have this top one written down. So we're going to skip that and do the last two here. Oh. Question 8. What does it mean for a polygon to be regular? Hint, there are two things that are true. All angles are congruent. Secondly, all sides are congruent. That is a must. If one of them fails, it's irregular. Okay? So if I asked you for an example, the best example would be equilateral triangle, right? Or a square. Or a pentagon if you can master, some of you can probably draw a pentagon better than I can print it. Okay, so you go for it. A hexagon has the following interior angles. Focus on that. What's the number of sides of a hexagon? 6, right? Hexagon, pentagon are the most commonly used, right? They show up in nature everywhere. Has the following interior angles. So 1, 2, 3, and there are 2 angles that measure 124. So these are, I will do this. 5 angles are given, right? 5 angles are given. So step 1, sum of a 6-sided polygon, right? I will find out what should they all add up to in the first place. Anybody have a good memory? 720, right? Use your calculator if you're not sure. So this would be step 1. Figure out how much they should all add up to in the first place. Then step 2, I will call that angle X, and I will start with the 720 I just found and start subtracting the angles. There are 224 angles, right? So you just start subtracting the ones you know from the 720. If this had been a 9-sided, obviously that 720 would be higher, right? Like it would be a different number. Then you start subtracting the ones you know. And if you do that, you get 111 degrees. This is an irregular polygon, since all angles are different. So even if this polygon had all angles the same except for 2, it would cease to be regular, right? Before you pack, this is a good review. Here, if I asked you sketch a kite and label 3 things on it, what would you do right now? Just put it down here. It should take you a minute max. If I asked you to sketch a kite and label 3 things using markings on it, right here, do it right now. See if you can get at least 2 out of the 3. I'm going to count a minute here. You got it? Okay, kite. It should not look like a rhombus. There you go. Boom, boom. Boom, 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 boom. Right? Property number 1. Property number 2, I'll do one of these. Put a 90 in there. Property number 3, this one, oh, I have to be careful. I have to use 3 marks, right? Because these 2 are cut in half. These 2 are not. Like the long diagonal is not cut in half. And one more, this angle is the same as that one. So I actually have more than 3 there. Are there any parallel lines on a kite? A kite does not have any parallel lines, so it's kind of unique from all the other ones. It does not have any parallel lines. I'm not talking in vain. I'm always doing something behind the scenes.